What's up, guys? Last video looked at the method behind titrations. We'll start looking at the calculations now. So, triangle, C, N, V, N being the number of moles, and units for that are just mole, C being concentration, moles per decimeter cubed, and V is volume. Which is decimeters cubed. Now, the interesting thing is you're never going to be given the volume in decimeters cubed. You're going to be given it in centimeters cubed. So we're going to need to remember to convert every single time by dividing by 1,000. All right, very important. So let's put this into practice. 25 centimeters cubed NaOH, unknown concentration. Right, so that's all one thing. We can group all of that together. Requires 8.3 centimeters cubed, 2 mole per decimeter cubed, H2SO4 to be neutralized. So again, if we're looking at our thing from last time, we're waiting until we get the final drop, we're doing our recordings, we're working out what our volume is. So we essentially have to use this equation to work out what our unknown concentration is. And again, I really like to present my information within a table. So we've got C, N, and V. We also need our H2SO4 and our NaOH. So neutralization reactions always have this sort of ionic equation, right? So we've got H plus OH minus makes H2O. The H plus here is from the sulfuric acid. We've got 2 of those. So we've got 2 H plus coming from there. Naturally, we've only got 1 OH minus, but we need to balance that out. So we're going to need 2 of these. So that's going to become important when we're converting one set of moles to another. Anyway, let's fill in our information. So 25 centimeter cubed of NaOH. So we've got 25 over 1,000. Again, we're straight away converting our volume into decimeters cubed. Unknown concentrate, 8.3 of sulfuric acid. So 8.3 over 1,000. And that we've got a concentration of 2 moles per decimeter cubed. So straight away, I've got 2 pieces of information here, missing 1. I need to do C times V. Put that in my calculator. What do I get? I get to 0.0166. Then I need to times by 2 because I've got a 1:2 ratio here. So my moles of NaOH are 0.0332. Next, I need to use these two to work out my concentration. So I'm doing moles divided by volume, N over V, and that gets us to 1.382. So that's our fairly basic one. We then get a bit more complicated down here. So we've got citric acid, water of crystallization, we've got NH2O. Citric acid is triprotic. So that sort of thing I spoke about earlier, this ionic equation, we're going to have 3H plus from the citric acid, made up to 1.52 grams of the acid was made up to 250 centimetres cubed. And then 25 centimetre cube portions are taken of this. So again, thinking about what we did last time, we've made our standard solution and we've used a pipette to remove 25 centimetres cubed. So that means whenever I work out my moles of citric acid, that's going to be the moles within my 25 centimetre cube portion. I'm going to need to know the moles in my 250 centimetre cube portion. So I'm going to make a little note to myself that at some point I'm going to have to times by 10. And I always do write that little note to myself as I go. And these are titrated against 0.05 moles per decimetre cubed of NaOH for neutralisation. And we've got this that shows us that. So let's start off with that. So my rough titer, I need to subtract my initial from my final, so I get 23.75. Really important that we're keeping it to 2 decimal places. Here, 23.15, 45.95, this minus this, and I get to 22.80. A mark will be lost if I put just 22.8. Same again for number 2, 22.80, and finally 23.10. I'm looking for concordant results, so within plus or minus 0.1 centimetre cubed of each other. Exclude the rough. 1 and 2 are the same, and 3 is too far out. So here my volume is going to be 22.80. If these were 2 different values, I'd add them up and divide by 2. If these 3 were concordant, I'd add all 3 up and divide by 3. Okay, now let's start putting our information in place. So I've got my citric acid. Let's just call citric acid Ca for now. And we've got NaOH. So we've got 3H plus because we're already told that it's triprotic. We've only got 1 OH minus coming from the NaOH. So we're going to need 3 of those. So we can now start putting information together. So this will come in 2 parts. One part where I'm using CNV, the next part where I'm using mass Mr. Mole. So we have 25 over 1,000 for citric acid. We have 22.80 we have 22.80 for NaOH, again over 1,000. And I've got a concentration of 0.05 moles per decimetre cubed. Now let's start working. So C times V to work out my moles here. And there I get to 1.14 times 10 to the minus 3. Here I'm going to need to divide by 3, and I get to 3.8 times 10 to the minus 4. And here's what I was speaking about before. This is my volume in 25 centimetres cubed. In order to continue working, I need to know how much I have within 250 centimetres cubes. So times by 10, 3.8 times 10 to the minus 3. So what we're talking about here then is our citric acid with water of crystallization. So I've got C. So I've got C6H8O7 dots NH2O. So my whole thing is I'm working out what this N is. So mass Mr. mole is the triangle we need for this. The mass we were given up here, 1.52. So our MR is going to equal our mass divided by our mole. And there we get to 400. So that's part one done. We've got our MR for this. We need to work out what NH2O is. So we need to subtract our MR for C6H8O7 because we know this. We're trying to work out the ratio between these two. That's going to be from our periodic table, 6 lots of 12 for hydrogen, plus 8 lots of 1 for hydrogen, this is from carbon, 7 lots of 16 from oxygen. Add those numbers all up, we get to 192. So, of our 400s, 192 of that is from our C6H8O7. So, NH2O MR is going to be equal to 400 minus 192, which is 208. Then we just need to work out what N is. And for that, we're going to divide by the MR for H2O, which is 2 lots of 1 plus 1 lot of 16, 18. So 208 over 18, that gets us to 11.5 reoccurring. But importantly, this has to be a whole number. So we round up there. So N is 12. A lot going on there, a lot of steps. I think the important thing to remember is that if we do this bit properly, here we get most of our marks. All right, these are for our final marks. So even if we're not too sure about those, follow as many of these steps through as possible and you'll get most of the way there. For now, give this question a go, screenshot, give a go, and I'll mark it. I'll go over the answers at the end of the next video. Happy revising, guys. Thanks for tuning in. Please like and subscribe.